All right, we're going to set up another example of actually doing the whole process here. Uh, we're we're going to take this piece by piece though, because there are a lot of parts to this. First of all, we're we're trying to actually find the area under a function between two values of x, and I've drawn out a picture of what that looks like here. Here's the actual function, and between 1 and 3 is the area that we want. And so how do we do this? Well, first, um, there has to be some number of boxes. Now we're going to work up to where that number is just n. But for now, and I think this number illustrates it probably best, we're going to choose 7 boxes. Now, 7 boxes means 8 points, and I'll show you what that means in a second. But we can already, and this is what I recommend as the first step, we can already say then that the distance from one point to the next should be b minus a over n. Okay, what is b, what is a? This here is from the lower bound to the upper bound, a to b, 1 to 3. So in other words, we're going to do 3 minus 1 over 7, which is 2 sevenths. 2 sevenths is going to be the distance from one point that we choose to the next point that we choose. So this is step 1. You have the actual function that you're dealing with, and you have the interval you're dealing with it. And you have the number of boxes you're going for. In this case, 2 over 7. We don't know what the number is, we would leave this as 2 over n, and that would be our delta x. In this case, though, we've chosen a specific n because I wanted to show you the specific example first before we get into the complicated stuff. And so in this case, when n is 7, it's 2 over 7. Okay. So how do we set up which points we are actually using? Because that is kind of what we're using summation notation to do. Well, we start with 1 and we go to 3. And the distance from 1 to the next is 2 sevenths. So, so this one right here is 1 plus 1 seventh. This is 2 sevenths. All right, starting over again. 1 plus 2 sevenths. 1 plus 4 sevenths, because you've added 2 sevenths onto this one now. 1 plus 6 sevenths. 1 plus 8 sevenths. Notice how we've jumped right over the number 2 is right in here because it's 1 plus 7 sevenths. We've jumped right over that. 1 plus 10 sevenths. 1 plus 12 sevenths. And then 3, which is 1 plus 14 sevenths. In other words, 1 plus 2. All right, now there's a reason I'm not doing the decimal for these. It's a repeating but very long and complicated decimal. If you want to see this written out slightly differently, you could write this out as, let's do a different color. What is 1? 1 is 7 sevenths, so you could write this as 9 sevenths. And then 11 sevenths. And 13 and 15, 17, 19, and then 21 sevenths. Oh, look at that, that's 3. And we skipped right over 14 sevenths, which is 2. And this is 7 sevenths. Okay, so if this looks like more of a intelligible thing. You can go with that. I'm okay with seeing either of these in your actual work as you're working through this, but um, I'm just trying to show that these are actually exactly the same thing, and this might actually be easier to help us get the summation formulas. So this is the first step, though, is actually writing out what x values you're dealing with. Now let's actually um, go through um, and we're going to do both left and right. We're at least going to identify both left and right um, points that we're going to choose uh, in this one step. So if we are doing a left-hand sum, we are going to choose, notice the left point would be this one would be x1, this one would be x2, x3, x4, x5, x6, and x7, and we wouldn't use this one at all. This is 3. Okay, we don't use 3, it's not a left endpoint, it's a right endpoint. So as you saw in the other video, you're choosing the ones on the you choose a left endpoint for the box that is here, and then you choose this point for the box that is here, and then you choose this point for the box that is here, and so on. So you never actually get to the 3. All right. If we are doing right endpoints, instead, we don't use this one. For this box, we use this point. So this is x1, this is x2, this is x3, this is x4, this is x5, this is x6, and we do in fact use 3 as x7. It is the right endpoint for this box here. Okay, so the 1 wouldn't get used at all in this case. All right, so now what that means is that for when you are actually setting up the formula for the area, remember what you do is you take remember this is approximate. We're estimating it using 7 boxes, and those boxes are going to be from I equals 1 to n, and in this case is 7, of f of xi delta x. That's how we approximate it. That is the formula, as you may remember from part 7. So now we have xi is already labeled for us for the left sum. Okay, so as you're going along, what you're going to do is you're going to, if you wrote out every single one of these terms, you would take 2/7. That would be 2/7. Here, I'll just write this below. If you were actually writing out each term, the area is approximately this, which is exactly equal to f of x1 times 2/7. That's the first box. F of x1 would be here, times 2/7 plus f of x2. Oops. Now notice it's not f of 2, it's f of x sub 2, which is this value. So you plug in the 2/7 value and get whatever the function value is at that point, which is the height of the box. Oops, we're at this point now. That's the height of x2, 1 plus 2 sevenths, or 9 sevenths, and you see what the value is, and then multiply that by 2 sevenths, and so on. Okay, let's take a minute to actually see what that would become. So I'm not actually going to go through the right endpoint in this example just yet. We're going to work out the full left-hand example first. Okay. All right. So so this right here. We need to come up with a way to identify what xi is, because what this is equal to is the sum from I equals 1 to 7 of what? Of f of x is up here, 16 minus x sub I squared times 2 sevenths. This is what we were actually taking the sum of. This times 2 sevenths. And then the next number, plug it into the function, times 2 sevenths. And then add the value of the next one, times 2 sevenths. That's what we're doing, is the 2 sevenths are each one of these segments here, and then the value of the function is the y value, the height. Okay, so if we can figure out a actual value for xi based on this, we can just plug that in. And of course, you can bring the 2 sevenths up front. And then you have 16 minus the sum 1 to 7 of x sub I squared. But that's the tricky part, x sub I. What is that in terms of I? Well, when it's 1, then you just have a 1. When it's 2, you have 1 plus 2 sevenths. When n is 3, you have 1 plus 4 sevenths. Something weird is going on there. All right. But notice they all have a 1, and you're adding some amount of sevenths. So let's see. The sequence here goes 0 sevenths, 2, 4, 6, 8, 10. They're all even, so let's put a 2. And then this is kind of skipping ahead to the interesting part, is if you start with nothing, then you're almost always going to do I minus 1. Remember, the index starts at 1, so if you are adding nothing here, if you have just a 1 and not a 1 plus something, then this term will be 0 for when I is 1, so that's just I minus 1. Okay, so now we know what this is, and we can plug that in here. Oh goodness. Alright, so this is now what we're dealing with. Okay, so 2 sevenths times 7 times 16. That's what this is right here. Minus the sum from 1 to 7 of 1 plus 2I over 7 squared. Now we're going to have to stop there, but that is what you will actually evaluate, and we'll continue later.